dt at constant volume is equal to ds dv at constant temperature. I mean, the thing is, you don't have to remember it. But the other thing is, it takes only 5 minutes to derive all four of it. Huh? So, I'll give you as some supplementary information in your exam. So, you just know how to use them. Okay. Okay, let me give you 1 or 2 examples today itself. Right. So then we come to the last one, dg, which is defined as dh minus change in ts. So minus change in what was dh? TDS plus VDP, I think. Just go up 2 pages and look at it. I think it was this one. If it doesn't come out right, I'll let you know. Yeah, that's right. So VDP minus SDT. So the natural variables are, of course, pressure and temperature, and that's what we've been seeing all the while. Colors have to be there. So what do we get? Why is math sometimes boring for me? Is equal to minus S del G del P at constant temperature is equal to volume. Yeah? And it goes up. So minus of del S del P at constant T is equal to del V del T at constant P. Right, I'm done with that. So you have these 4 fundamental equations of thermodynamics and 4 Maxwell relations that come out of it. And somewhere you can see these square things which tell you some mnemonics to remember these Maxwell relations and the fundamental equations, but I think that's not necessary because it's quite straightforward to remember that du is equal to dq reversible plus w reversible and then derive everything from there. Yeah, if you guys want to look at these shortcuts, which I'm not really interested in, but you could search for something called the thermodynamic square. Might aid in your memory to remember all these 8 equations. Okay. Now, these fundamental equations are very, very important, of course, and so are the Maxwell relations, and whatever the thermodynamics that we are going to build from now on will be based on these equations. In fact, most of it will be based on an argument of Lipin's free energy. But you realize that all of them are interrelated. Yes, just starting from du, I could get all 4. If I can get all 4, I could start with dt and get the other 3 as well. So they are all interrelated, all these relations. Okay. So, since you asked for an example, I have one over here. Remember, we did the Joule expansion, right? And immediately everybody, when I asked you, and I didn't want to trouble you at that time because I knew that you will not be able to solve that. But everybody of you, all of you, you said pi t. Remember that pi t? Change in internal energy as a function of volume at constant temperature. You said it's zero for ideal gas. How did you say it's zero? Just because you've been taught that it depends only on the temperature, right? So let's see how we can actually evaluate that now. So we'll evaluate pi t. So to evaluate pi t, what I need to worry about is du. And we've just seen a couple of minutes ago that du is a function of entropy and volume, so I'll write it like that. Change in u as a function of entropy, volume constant ds plus change in u with volume, entropy held constant dV. Now what I want is du by dV. So let's do that. Du by dV on the left side. I just divide everything by dV, and the condition was temperature constant, so I'll take that. The first term is just kind of a slope. Now, for those who are trying to understand, this is the kind of slope in the S direction. That just tells me how much u is going to change if I make a change along S. This is a slope along the V direction. So these are kind of constants. So when I have to divide by dV, I don't need to divide those numbers because those are anyway constants. So what I do is del u by del S V, del S by del V, constant temperature is what I have to worry about, plus del u by del V at S, and del V by del V is just 1, so I don't need to worry about that. So that's pi t, yeah, that's pi t. Now, although there are many ways of doing it, and you could do it, but just use the Maxwell equations. Okay. Or use the fundamental equations and tell me if you find anything that matches del u del S or del S del V or del u del V at constant interval. Just have a look at these 8 equations and tell me.
You put del S by del V at constant temperature.
Sorry?
You put del S by del V at constant temperature.
Del S by del V, what is it?
In the third equation, del V by del V at constant temperature.
Luckily I have the entire thing in one sheet, so. Yeah, what is it?
You got it equal to dou P by dou T at constant volume.
Dou P, dou T. So this comes from the Maxwell equation from dA, from Helmholtz free energy, right? dP dt. Right? Anything else? Just see if del U del S at constant volume. Temperature, very nice. Which one? Which equation does it come from? The equation for U. Okay. So del U del V at constant entropy minus P. Oh, that's lovely. I start with all these various energies, U, S, entropy, Falana, Dhimkana. What I've got my equation in terms of observables, things that I can measure. Temperature, pressure, volume. That's great. Because these are things that I can measure. So I don't have to worry about it. I just do that measurement and find out the pi t.
For an ideal gas, this is 0 now.
Now we come with it. So, पहले भी कैसे बोला था?
ऐसे बोला था कि
अच्छा, ये क्वेश्चन देखी नहीं होगी यार. Yeah, now for an ideal gas, of course, we can put dB dt is equal to nR by V, and nRT by V is nothing but pressure, which is 0. So that solves for an ideal gas. Well, you can even do it for a van der Waals gas. But no, what I am saying is that not just theory, but experimentally also you can measure temperature, you can measure pressure, you can measure volume. Or you could hold one of those constants and you can measure the rest of the things. Even experimental values of phi t you can get if you ask such an equation, because now you know what to measure. When phi t was defined as del u by del s at